Oh, shit. Here we go. What? What? Professional coding here. Yeah, fuck that. I don't care. Oh shit. God, I hate. Oh shit. I hate JD Vance here. Y'all think I have my attention on you? Fuck that. I'm watching a video right now by JD Vance. Couch fucker. better. Looks cleaner. Wait, what? Oh, come on, VS Code. Let's do color. What else? No. We'll have more to do. Values yx x max. Wedge values wedge height. What does that mean? Is that y? Yx x max. Yeah. Collision group. Yeah, we don't have to do that janky system. And the y. Fuck is C-frame? Where are you in this shit? Fuck is C-frame defined? Oh. Naughty, naughty, naughty. Oh well, good enough. I don't care. We'll see. Alright. Thanks. connected, right? Yep. Forward view. I could do that. And I probably should. Alright. God, this looks genius! Except it's actually stupid. Stupid idiot! Just gonna set them all manually. Part. I'm just going crazy. What's this? What's this? Why do I have a black line VS Code? Oh, I see. That's really weird. I want a theme here. Expert coding here. Be good. Theme darker. Wow, it's a great theme. It's literally like theme flat. Excuse me, theme mix. This looks like shit. Ooh. I like that. Ugh. I think colorblind looks very nice. Alright. Paint wedge. Now we need to add it. Alright. Add a chunk grid. Chunk grid. It's not defined. Beautiful! This thing's genius. Triangle. Here it is. So after we add it to the chunk grid, we destroy it. Oh. Attempt to index null with number. Fucking knew it! The fuck? It's right. I see it right there. What's the big idea? Attempt to index nil with number. No, I don't care. Why would I care about any of this? I literally do not care. I do not want to watch Moist Critical right now. Dude, why am I getting Moist Critical? I do not want to watch him right now. How have I not subscribed to this guy? Okay. Let's do this. Anyway. So there's an issue on this line. Attempt to index nil with number. So that would be XY parts part info. Does this literally change live? If I put an A in here, I'm gonna go into this script. Quite the fidelity. I don't fucking know. Does it? That would be cool if it did. Yeah, okay, that makes sense. Second. If it crashes, I'm killing myself. I'm telling you seriously. I'm not gonna wake up tomorrow if this. I'm going to shoot myself in my head. Okay, great. This is so simple. Dude, this thing's moving faster than me. Give me a second, bro. That's why it's not working. No errors, that's fine. the junk road, buddy. Internet. There we go. Here we go. Holy shit, this is a lot of... C-frame, color, material, size. I mean, perfect, really. This is exactly what we want. But we have the parts there for some reason. My God, shut up! I'm sorry, what does this say? Why are the parts not destroyed? What? Oh, I forget. These are the poles. Never mind. That's fine. We haven't added the poles to the part list yet. Honestly, I think it's fine having the poles always loaded because of their low part count. I don't know. It depends on what we're going to do here. Oh well. Uh, let's call this. It's literally exactly what happens, buddy. Whoops. Dude, I am amazed by how good this cursor system is. Honestly, it's so nice. Hmm. Do we need anything else here? Well, no shit, we need anything else. So what do we need next? So, proprietary grid. We need to get the planet. Okay. Tab. I'm pressing the tab key. Hey, fucking VS Code. I'm spamming. Okay, there we go. Finally. God, dude, I'm trying to code here, but like the AI is literally doing it for me. This is incredible. Oh yeah, it is. Yeah, it is. Oh well, it doesn't matter. Okay, so what I'm gonna do here is set this to 2000. And basically, if we get a nil result, that means we have no planet within 200 trucks of us. So we'll do basically if lowest base, then return lowest grid, else we want it to return nil. But I also want to warn, can't do that there obviously, warn no planet found. Okay, so if we have no planet found, then we don't want to load any chunks, right? So basically, if not chunk grid, then we want to define it. So if we have a chunk grid, well, we're never gonna have a chunk grid, so I don't even know why I'm putting this here. Okay, so basically, we want to get this is gonna return us a grid. So equal grid equals module dot find chunk grid part. And now we want to check if there is a grid. If not grid, then no chunks. No chunks. Not loading anybody. Little man. Return. Okay. Honestly, we have a few options here. So let's find the grid we're in. Dot find grid on part chunk grid. And honestly, this is like a really stupid solution, but I'm just gonna go through the grid and see which one has the I told you this is bad. I'm gonna go through the grid and find the one that has the closest magnitude to the player. But to do that, I want to create a part at the center of the grid. Because I don't want to loop through every part of the grid. That's way too much. That's like way too much. I mean, I could just get all the part C-frames and I mean, yeah, I could just get all the part C-frames and average them. I mean, I might be able to just loop through them and would that work? Let's see here. Let me look this up. Actually, while I'm looking this up, I have a AI right here. Let's see. Let's give this guy a test. How do I average between a list of C-frames? Sum up all the positions and orientate Y. Divide the sum by the number of C-frames. Okay, we're not doing that. 1 second. Okay, I had an idea, but that's actually a really bad one because I would still be looping through the C-frames. Okay. Local get chunk center position. No, this is a function. We do local chunk center. Yeah. No. Module dot get chunk center position. Let's do module. What? Why is there two ends? Look at chunk position, right? And I probably want the chunk grid too. No, I want the chunk. So we could do loop through the chunk grid. So two. Okay. So we want to get the chunk position. So we'll do local chunk position equals module get chunk center position. The part and the chunk. So that's yeah, we can do local chunk equals chunk grid x y. Okay. No, we don't care about part. Why would we care about that? I don't think we should really be doing this here. Okay. So to create something in the center, the X amount and Y amount. So the Y amount, my Y is an iterator amount. Here's the number of X's we have. And to get the central, we need to get we need to get that value of that position. So we do local x center equals x amount times, or x times chunk distance, which should theoretically work. I don't see why that wouldn't work, right? Same for y. We're gonna find that in here. Will it do it? Let's see what the IR has to say here. Oh man. Y center equals y times chunk distance. So now we need to figure out, because this theoretically, right, is going to give us a part at that exact location. No, oh shit, no. So we have these two values and we want to get the closest part at this position. Alright, so we need some data here. So let's do function get closest part at position. We're going to need the x and y value. These are going to be grid values. We don't care about the, well, do we care? No, we don't care about the chunk grid. We care about the planetary grid. So just grid. Yeah, grid dx and y. So that means we're going to need two things here. A, we are going to need the planetary grid here. No, we don't. We need the sphere constructor. Yeah, we need the sphere constructor of the planet, and that's basically going to give us access to its grid system. And I don't know if we need to, but just in case here, I'm going to define local grid module equals require. We need the grid module, which is, no, it's sphere module, my bad. Equals require we are the chunk module, so script.parent.sphere module. Alright. So now we have the sphere constructor. First thing we want to check, we want to define local grid. And I actually want to open the sphere constructor here to make a change, because now we have to adapt the sphere constructor to work with nil results, which it before is not able to deal with nils. It crashes out. So we'll go to sphere module, which, probably should have been fixing it. Buckle pos equals. So we do if grid x, then local pos equals, paste them in there, and then we'll do, it was grid x, so we do grid x and y and grid x and y or no. So basically, if this is a ternary operator, basically if the position exists, then it will return that. Well, I don't know if we're actually going to need this, but first off, we just want to make sure that this, first off, we just want to see if this works, because that would make things easier, right? Because if we just, instead of having to find it, if we just straight up run it with the exact coordinates we get a result, then we're all good. So here we need the sphere module. sphere. So yeah. So we're going to take in the sphere constructor here. Okay. So I need this sphere for you. So the chunk in the sphere. So we want to do local position equals sphere dot get position. You can see here if we go to the sphere module, we have a function called get position, and we want to do the chunk. Whoosh. Okay, so we want to the chunk x and y. So we want to get the chunk x and y here. So we'll do x and y. We'll do x chunk, y chunk. Chunk! God! Okay, and now we want to do local x chunk equals x chunk you have x center here. Okay, so position here. That's what we want to do. Let's do position is going to equal create center position, and what we want is the x center, the y center, the sphere module, and I think that's it. So let's do create center position. Oh, are we all out? Huh. No, we're not. I wonder why it's not giving me suggestions. Okay, function, create center position, x center, y center, sphere. So what we want to do is do local position equals sphere dot get position, x center, y center. We do if position, then return position, end. So if we have the position, then we got lucky and we already had it, so we don't care. If we're here, however, that means we do not have the position. So we need to find the closest part. So to get the closest part, what we can do, I'm actually getting rid of this function, I think. I'm not sure exactly what it's for, but I don't think we're going to need it. We want to basically go through the grid. So we need the grid. So what we can do is do sphere module function sphere functions dot get grid. Do if grid, then return grid. Okay, that's a pretty simple module, and we'll do if grid. So local grid equals sphere dot get grid. We do if not grid, then warn no grid found, return nil end. Okay. What? Only one statement per line is allowed. Why? I think Slane's using an outdated version of Lua. The Lua U interpreter is fine with this, so I don't know what it's going on about. Okay. So now that we have the grid, we want to go through the grid, and we want to find the closest part. So we want to get two numbers and see how close they are. So to do that, we can create a local function closeness. I mean, honestly, that's really simple. There's this really complex thing called arithmetic, and we can just subtract the numbers. It's very complex. So let's generate the closest x value. So let's do 4 underscore, no, actually, okay, 4x x value z table or y table in pairs grid do. So we want to do, so the x value, this is I believe x value is going to be our, yeah, x value is going to be a number, and we want to check if our x value is closer. So what we could do is do what we did before, local closest x equals, and we'll give it an impossible number, and local closest x num, and then local closest x. I don't want to closet it. Closest x. Okay. And now we want to do the same thing. Okay. Hey, I don't care. Could not care less, bro. Hey, shut the fuck up, Celine. Okay. So now we want to check. I'm going to do local x difference equals a math.absolute. So basically this means we don't care which way. And we want to do closest x num, take away x value, I don't care if the x num is in the closet. Okay, I'm not judging, but I would like to spell it correctly. Okay, so we have our closest x num, take away our x value. No, we're going to do x value take away, okay, and of course there's a vacuum right outside my fucking door. Closest x value, so the x value is the value of the x, and the closest x num is the difference between them. So we can do if x difference is less than closest x num, then closest x num equals x difference, and closest x equals x value. Okay. We did it, yo. Okay, now let's go through the y value. So for y value, y index, no, okay, you know what? We have these backwards. Let's do x index, x index, x index, y value. We want to do y index, y value in pairs. Holy shit, y table! I think. So this is going to be, y value is going to be a C-frame. I don't think we care. So yeah. Now we can do no. Like I said, I do not care if the closest x num is in the closet. I just need to spell it right. Closest. Never used. Are we positive? Pretty sure it is. Is this correct? No, it's not. We want to do the x center value, right? Yeah, so we want to do x center. If x difference, correct. Okay, so this is what we want. Okay, I gotcha. I got you, man. I got you. I got you there, bro. Okay, and we can do y difference equals y over y center. If x difference is above closest y num, then closest y num equals y difference and y index. Okay. So if not closest x or not closest y, then return nil end. And we also want to warn invalid x or y, buddy. And once again, the Lua U interpreter will accept this. I do not know why Slam's warning it. Okay. Is there anything else we need to do here? So we have the closest x, we have the closest y. We want, now that we have it, right? I think we just want to return it. Then we do position equals sphere dot get position closest x closest y return position. So this should keyword this should take the x value, multiply it by 5. So yeah, if we do math.floor in the calculation, yeah, we do when we're adding an object to the grid. We do get chunk location, which Yeah, it uses math.floor to find the nearest integer. Which, I think I'm seeing an issue. Oh well, we'll see. Alright. So now we have an object at the position. So going up here, we don't have to get it. We can do chunk position equals, we don't require sphere anymore. Chunk grid or chunk what's it, position. Well, will return us a C-frame. Okay, so for the iterator x table, okay, y table here, and inside the y table is the chunk information. But I think we define it right here. Okay. So we have the C-frame from the chunk. And what we can do is do, yeah, we can I think we can literally just do the same thing we were doing before and find the nearest chunk. Yeah, and basically we're doing what we were doing before, but instead of finding the nearest part in the nearest chunk, we were instead of finding the nearest numerator in the index of planetary objects, now we're finding the nearest chunk, x and y. Okay. I need a second. Alright, we're back. Oh shit, I forgot. And by the way, these big values are a substitute for Matplotlib and stuff. Actually, just to make things easier, I'll define it. So we're getting some good progress here. So find chunk grid finds the nearest planet, right? Lowest magnitude is equal to 2,000. And the reason I'm doing that is because this is the maximum distance I want to detect for a planet. So we're looking for up the planet. Once we find the closest planet, we'll return it. If there is no planet, then we'll warn no planet. So grid, module find grid chunk, warn no planet. If not grid, then this basically will fire because we do not have, we're not near a planet. Now, to get the nearest chunk, equals find grid on part. We care about part position and grid. We'll do if not nearest chunk, then, and basically I'm gonna then warn no chunk, return no end. All right. Finding grid on module, sorry. Alright, so module.find grid on part position grid. So if we're getting the nearest chunk, we need to load the chunks. So let's do function module.load chunk. This is going to be the actual chunk object. Now we want to do a deload chunk. We'll worry about that later. I'm interested. Actually, I'm in. Okay. So what we want to do is we want to take our render distance. Do we have our render distance defined? So we have our chunk distance defined, but we want our render distance defined. Eventually, I think it's worthwhile to add a configuration system, and then we'll get the render distance from the player themselves. But for now, let's just do render distance equals 5 chunks as well. So we want to get 5 in every direction, including diagonal. Okay. So let's do local chunks to load equals module.get chunks from branching from chunk. Get chunks branching from chunk, and what we want is the chunk, which is nearest chunk here. And then we could do module function module dot get chunks branching from chunk. Basically what we want to do with this function is we want to go through the chunks, and we want to basically get our render distance. Our render distance is 5 in this case, so we want to get 5 chunks, quote unquote, in front of the chunk, and 5 behind, 5 to the left, 5 to the right, and all the ones in between. So what we could do is we also want so we also want the chunk grid. Okay. So for I equals 1 render distance, do and if we go here to the chunk module, I'm interested to see if we go ahead and save this, and I just want to see if it would be any better to code in here, just as a test. So if we go here to where we are at, so for I in render distance, what we want to do is effectively we want to get all the chunks in a 4 below 1, 2, 3, 4. So that's 1, 2, 3, 4, 5, 6. Okay. Okay, this is getting more complicated than I thought. Ooh. Okay. My brother is crashing out right now. Okay. So then what we could do is for x equals 1 through render distance, do. And for y equals 1 through render distance, do. So we are getting x add, y add. And if we go ahead and save this, go ahead and publish this, and we go ahead and copy this over. So what we want to do is we want to get the junk using this. So we'll do local new chunk equals. So we need to get the x and y value of the current chunk we have. So we have the value. I want to get its ancestor, if that makes any sense. Let me see if that's possible. Okay, my brother is literally crashing out, my 4-year-old brother. Here's the thing we can do. We want to return the x and y values here of the chunk. Yeah, I think that might work better, honestly. Nearest chunk, x, nearest chunk, y, and we can do local nearest chunk equals, yeah, we have grid nearest chunk x, nearest chunk y. If not nearest chunk, then get branch, and then we could do nearest chunk x, nearest chunk y, and then we need the grid go define the grid on part real quick. Where is it? Here we go. And we want to set our chunk position to what's it? What's chunk position? Chunk. Whoops. Nope. Grid. I remember now. Chunk equal, yeah, we want to return x index and y index. So we want chunk position x, chunk position y, so if not chunk position x or not chunk position y, then warn no chunk position, return chunk position x, chunk position y. Okay, so we want to do new chunk equals chunk grid what do we better to use? Get chunk location xy chunk grid. Would this be better? What does this function do exactly? Get chunk location x. Okay, so this converts planetary coordinates into coordinates on a chunk grid and returns the chunk grid. However, we don't want that. Yeah. Because yeah, especially with this, we want it to wrap around. So you could do function module. Okay, we could do. This is going to be a local function, since I don't think we're going to use it anywhere else. So I'll define it at the top. Local function index chunk grid. We want x, y in the chunk grid. And basically, we need the maximum x. Sorry, my brother is crashing the fuck out right now. I'm sorry. Okay. Should not be laughing at a 4-year-old. Okay, we want local max x equals number of chunk grid. Local max y equals number of chunk grid 0. We want to do, if x is above max x, then x minus equals max x times 2. No, sorry, whoops. Yep. Okay. Not with max y though. That's the way it's calculated. Alright. Then we can do else if x is below negative max x. Then x plus equals max x. Let's do the same check for y. So do if y is above max y, then y minus equals max y. Else if y is above negative max y, then y plus equals max y. And so now we want to check if this exists. to the if, I do not care, believe it or not. Okay, if chunk grid x, then we do if chunk grid x y, then return chunk grid x y, and then for else of both of these we can just else warn y failed index chunk, and then for this we can just do else warn x failed index chunk. Okay. Now we can go to here. Index chunk grid. X, Y, and chunk grid, which makes sense. X, Y, chunk grid. We'll do if chunk grid, or if new chunk, then, and we want to add to a list chunks. If plus x add plus y add, and we want to do negative render distance. To render distance. The reason we're saying negative render distance here is so that we get all the chunks also behind the player, which there's no concept of behind here, but on the sphere relatively. And so the local new chunk is going to be this chunk, and we do if new chunk, then table dot insert. I think it's insert, right? Or am I going crazy? Yep. Okay. Chunks, new chunk. Okay. So now that we have this new chunk, we can return chunks. And we also want to do another value here, which can make things easier. Local fully chunks equals true by default. However, if we get this, then we'll do fully chunks equals false. And what this basically means is that we're going to return chunks and then fully chunks. Basically, this is going to, and I'll also warn chunk not found. Basically, when we send this to the thing, the chunks to load, and the chunk check. If this value equals false, then we know a chunk failed to load. And I'm not sure if that's going to be entirely important here, but yeah, we're going to have a table here. So we want to do for underscore chunk in chunks to load, or in pairs, sorry. Chunks to load, I'm great at spelling, I know. Do, and we want to load the chunks. So what we can do is load chunk. Module, sorry. Okay. Now we need to check. Okay, I think that's where I'm going to stop for today, because we have a lot to do. The next thing we need to add is to check, and this is all untested code, by the way, which is going to make things so much more fun. I can't wait to see what breaks and how many functions we're gonna have to create. But yeah, the next thing we're going to do in the next video is we're going to unload chunks that are loaded. So we're gonna have a value of all the loaded chunks inside of a chunk, and to deload a chunk, we want to we want to check when there's no players near that chunk, meaning that it looks like here I am volunteering to do a server-sided chunk loading approach, which is, you know, it some people don't like it, but I think it's just gonna make things easier here. But yeah. Yep. Yeah. So yeah, the next video we need to check when a chunk is unloaded and the nobody is near it. Nobody is near the chunk. So yeah, when someone moves and a chunk deloads, check. We go there and we check. We're basically going to we're gonna have to do a lot of stuff with parts, adding them to a list of total parts on a specific chunk grid. Check if any of those parts are within a render distance of the chunk grid, and if they are within that render distance of the chunk grid, then we don't want to unload it. However, if they aren't, then we can go ahead and unload it. So a lot of things to consider here. This is going to take a while. So let's go ahead and save everything here. Let's go ahead and publish this. And let's close out of all of this. Alright.